Hi.
Hello, Arjun. It's great to meet you. I'm looking forward to our conversation about your experience in DevOps. To start, could you share a bit about your background and how you got into the field?
Yeah, sure. So this started off early on in my career, back in 2013. I was doing a part-time as a sysadmin, in which I was mostly looking into managing Windows-based servers, and it had a few websites that were hosted on it. It was more of a bare metal two machines that we were using, and apart from that we also had a few machines that were on-prem in the office as well, which had like a domain-based login and everything, in which people would log into the machine, like to the actual server, and work on that. And that's where a part of my sysadmin, or server administration experience came in. Bridging in from that, I started off with DevOps around about 2019. So I did 3 years of sysadmin work, and then I did my master's. And in 2019 is when I actually got into proper DevOps, MLOps sort of thing, basically. So in 2019, what I started off with was Kubernetes and AWS cloud, and most of our environment was primarily based on AWS itself. So my whole experience in server management, sysadmin, and scripting, and all of these things, they kind of just tied in directly to the whole DevOps experience from 2019 onwards. And I've been working on and off on this itself for, like, I don't know, at this 2019 to 2025. Yeah, that's basically my exposure and how I got into it.
Thank you for sharing that, Arjun. It's interesting to see how your journey evolved, especially transitioning from a sysadmin role into DevOps and MLOps. Given your experience, I'd like to dive deeper into your DevOps work. You mentioned working with Kubernetes and AWS. Can you share a specific example of a challenge you faced while managing these environments and how you addressed it?
Okay, so one of the biggest, hurdles or challenges that I faced while managing Kubernetes and on AWS was managing like GPU-based workloads. So we were using machine learning based containers, or Docker containers that had ML algorithms running in it, and some of them were on CPU, some of them were on GPU. And one of the biggest things when it comes to DevOps is cost optimization and right sizing the instances that we're using. So one of the biggest challenges that I faced was picking the right instances for the kind of workload. And the way I did that is by doing load tests and benchmarking to see how much utilization of the CPU and memory and VRAM is actually getting used when the machine is at load. And that's how I would figure out, what's the relevant machine to pick for any workload. And after that, I would set that as the node selector, and based on that, all these workloads would get scheduled into the relevant machine. So that's one of the challenging aspects that I worked on so far.
That's a great example of facing a real-world challenge in DevOps, especially with the complexity of managing GPU-based workloads. It's clear you put a lot of thought into right-sizing your instances for efficiency and cost optimization. Building on this, how do you ensure the stability and scalability of the Kubernetes clusters, especially when you're running a mix of CPU and GPU workloads?
Great question. So the way I would do that is, I had a CI/CD pipeline in which load testing was built in. So the way we would do it is, like, first stage would be just sequential load, just one user hitting this same or similar requests to the model for like 10 to 15 minutes of time. This would help us identify if there was any memory leak, or memory stacking that happened in the way the container was deployed. Because one of the pitfalls of machine learning based workloads is memory stacking and memory leakage. So once we would go through this process, my second load test would be with concurrent users. So actually there were like three tests with concurrent users. So the way I would go at it was with 10, 100, and 1,000 users, and this would give me some indicator of like how well a single container would scale out. So once I had a good idea of how much load one container could use based on the requirements, like how many users are expected to hit this workload, I would set the auto scaling policy between 0 and 10 or 20 or whatever be the count based on the workload. So that's how I would select the instances and the number of instances needed for the workload, the target workload that we have basically.
It sounds like you've developed a robust approach to testing and scaling your Kubernetes clusters, which is crucial for maintaining stability and performance. Your strategy of using load testing and adjusting the auto-scaling policy based on real data is insightful. Building on your experience with auto-scaling, how do you handle situations where there are sudden spikes in demand? Are there specific tools or techniques you use to ensure the system can handle these efficiently?
Yes. So actually, what we would do when it comes to auto scaling is there would be a threshold of buffer that would be allowed for each workload. So what we would usually do is by default the threshold would be around 70% or something. So what that would do is like the moment we cross 70% threshold of, let's say, the CPU utilization or memory utilization, we would still have 30% buffer before the next machine scales up and starts responding. So for the most part, like these containers tend to be huge, they take their own sweet time to come up. And if it's, let's say, a GPU based workload, if we do not have a GPU node available in the cluster, what would happen is it might take like 3 to 5 minutes, even sometimes up to 15 minutes for the machine to come up if, let's say, nodes are not available from the cloud provider. So having this percentage buffer of, let's say, we are allowed to scale beyond this, like while being able to respond to requests, is how I would ensure that if there's like random spikes that would come in, it would handle it up to this threshold percentage. And the moment it would hit 100%, of course, then it would no longer be able to handle it. But apart from that, I would also make redundancy a primary factor. So when it comes to production systems, we would ensure that we have at least of the least bare minimum of three replicas per workload. So that, and not just that, we would also ensure that all of these three replicas get scheduled in different machines. So that way, if, let's say, one machine goes down due to, like let's say it goes out of memory or something fails on the cloud side, we still have two machines that are like up and running and ready to respond. So apart from the threshold, having this redundancy and making sure that it's split across multiple machines evenly, that's one of the things that I did to make sure, like the system gets scale and that it can handle random spikes if it comes in. On the flip side, if, let's say, we know that the load is going to be a predictive load, like let's say, um, if let's say we have like a application that's streaming video or something like that, and we know that there's a show coming up or a live stream that's coming up, what we can do is we can have like a scheduled scale up. So if, let's say, we know that the show is going to start at, let's say, 9 a.m. in the morning, we can do a preemptive scale up to ensure that when that expected load comes in, we are ready to take on that load. So that's another way I would go about it. I haven't really had a use case for using it, but that's one way I would go about it.
Your approach to handling both unpredictable and predictable spikes is comprehensive. Using a buffer threshold for auto-scaling, combined with redundancy and spreading replicas across different machines, shows a strong understanding of ensuring availability and performance. Preemptive scaling for predictable events is a smart strategy, even if you haven't had to use it yet. Given your experience, how do you approach monitoring and alerting in these environments to ensure you're aware of issues before they impact users?
Great question. So, one of the strategies that we go about is Like based on regular usage, we can set thresholds and alerts that come in case, let's say, some issue kicks in. So, I mean, to be a little more specific on that front, like let's say we have a Redis cluster that is being used by the system. One of the alert policies that we would set on not just Redis but any sort of storage or something as a de facto is, let's say, storage is crossing 75 or 80% threshold, and based on how, how quickly we know that, the earlier we know it, the more preemptively we can actually scale it up, or take a look at it as into what's happening. So for the alerting part, what we've done is, for the most part, we've used Slack itself, and reason being, our workload is not entirely customer facing, at least in my current org. So we don't really have like a 24/7 availability SLA at the moment. Although that's something I have had before, and for that, what we used to do is we used to use PagerDuty as one of the ways that where we would page an on-call SRE or a DevOps engineer. Alternatively, we have also considered using Grafana IRM as well, considering on purely on the cost factor basically. So that seems to have worked out a slightly more cheaper option in our case. So these are some of the ways how I would alert an on call engineer, and how I would do the alerting based on thresholds of usage and systems that we've built.
You've outlined a solid approach to monitoring and alerting, with proactive thresholds for storage and using tools like Slack and PagerDuty for notifications. Tailoring your alerting strategy to the needs of your team and workload is key, especially when not all services require 24/7 availability. It's also wise to consider cost-effective options like